everyone, this is Miss Cassidy. I am going to be talking to you guys today about polygons. Now, I know that we have talked about polygons a little bit in class, but I need you to right now get out your math journal and a pencil because you're going to be taking some notes. The first thing I want you to write down in your math journal is the definition of a polygon. So if you look right here on the screen, it says a polygon is a closed plane figure formed by three or more line segments that meet at points called vertices. Now that might sound confusing at first, but if you break it down, it makes a lot of sense. A closed plane figure means that all the sides are closed in, so there's not going to be an open end. There's going to be three or more lines, which means a triangle is going to be the fewest number of lines that a polygon would have. If there's just two lines, then there would be an open end. And they all meet at points called vertices. All these polygons have vertices. So you see right here, this is where two lines meet. So that's a vertices. This is where two more lines meet. So that's a vertices, and so on and so forth. Each of these have vertices. Now, there are different types of polygons, so not all polygons are the same. The polygons are identified by the number of sides and angles that they have. So, for example, a triangle has 1, 2, 3 different sides, and how many angles it has is determined by the inside measure right here. So I have one angle right here, one angle right here, and then another angle right here. So it has 3 different angles. And it's going to have the same number of vertices as it has angles. So because that's where the two lines meet, forms an angle, it also forms a vertices or a vertex. So right here I have a vertex, vertex, and vertex, and I also have an angle, angle, angle. So there's 3 angles, 3 vertices, and also 3 sides. Now we can also look at a quadrilateral. That's going to have 1, 2, 3, 4 sides, and it's going to have 1, 2, 3, 4 vertices, and it's also going to have 1, 2, 3, 4 angles. So when you have a quadrilateral, there's 4 sides, 4 angles, and 4 vertices. So if you can kind of catch on, there's actually kind of a pattern going on where you can see that the number of sides equals the number of vertices, which equals the number of angles that the polygon will have. Now, real quick, again, I'm going to make sure you understand what is going on here when I'm talking about angles, vertices, and sides. So an angle is this inside part right here of the polygon. It forms an angle. Now, not all the angles have to be the same measurement. In this case, they're all congruent, which means they're all the same angle right here. So those are all angles. So when I'm talking about an angle, it's this inside corner here. Now when I'm talking about a vertices, that's this little point right here. It's where two line segments meet together. So this right here is actually, when I'm talking about a singular vertices, I'm going to call it a vertex. But when I'm talking about more than one vertex, it's called a vertices, or they are called vertices. And last but not least is a side. Those are these line segments right here. This is a line segment, this is a line segment, this is a line segment, and this is a line segment, and this is a line segment. And so we can call them line segments or sides. So actually, if we look at this one, we can determine what kind of a polygon it is by counting the number of angles, sides, and vertices. I see right here that I have 1, 2, 3, 4, 5 vertices. How many angles do I have? 1, 2, 3, 4, 5. And how many sides do I have? Well, I have one right here. 1, 2, 3, 4. I have 5 sides. So I have 5 vertices, 5 sides, and 5 angles. So if I go here and look at my chart, I know that a pentagon has 5 sides, 5 angles, and 5 vertices. And now not all pentagons are going to look exactly like this, because a pentagon just means it has 5 sides, 5 vertices, and 5 angles. So it could look like this, or it could also look like this pentagon right here. The only thing you have to be careful about with a pentagon that looks like this, or in some cases decagons, nonagons, all of these different angles, is that even when the angle is going inward, that doesn't mean that it is not a angle just because it's going inward. In that case, it just means that it's going to be greater than 180 degrees, but it's still an angle. So don't forget that. All right, so the next thing that I want you to write into your math journal are what the number of sides each polygon has. So what I would like for you to do is pause the video, and I would like for you to make this list in your journal. I'm not going to make you write out this whole chart, but as long as you understand that a triangle has 3, quadrilateral has 4, so on and so forth, and then you should be able to know that by 3, I mean 3 sides, 3 angles, and 3 vertices. So go ahead and pause the video and write that down. All right, so you should have written that all the different polygons and how many angles, sides, and vertices they have in your math journal. The next thing we need to talk about is what does congruent mean? Because that's going to be important when we're talking about polygons. Congruent means identical in form. So when I'm talking about identical in form, I could be talking about their sides. Are they identical? Do they have identical lengths in their sides? Or I could be talking about angles. Do they have identical angles? Are all the angles the same? So if we look here, I could have congruent line segments. So in this case, if I'm looking here, congruent line segments means that the length of the line is either the same or different. But how do we determine that? Well, if I am looking for whether or not a line segment is congruent or not, first thing I'm going to do, I have they almost look like little asterisk, not asterisks, little like quotation marks or something. There are these little lines that I'm going to draw on the sides to show congruent line segments. So if you look here, I have a congruent line segment right here. So this little line means that this line is the same length as this line. It's also the same length as this line, and it's also the same length as this line. How do I know that though? Well, I know it because I have a line going right here, one line going right here, one line going right here, and one line going right here. Now I can't count these 2 line segments, okay? These 2 sides, they're a different length. So I have to look at them. But if I look at them, they are congruent. These 2 are the same length. So what I'm going to go ahead and do is I'm going to mark those with 2 little marks. So if you look right here, I have 2 marks right going right there and 2 right here. So that shows me that 1, 2, 3, 4 of these sides are congruent, and then these 2 sides are congruent with each other. Now, sometimes there's actually going to be a third set of line segments that are congruent with each other. In that case, you would want to go ahead and mark them with 3 different lines, like this. Now, in this case, there isn't a third set of congruent lines, so I'm not going to need that for this particular polygon. But if I look here, I see that I have one set of congruent line segments here and another set of congruent line segments here. So there's 2 different sets. Now talking about angles. The angle, remember, is that inside curve of the vertices. And when I have congruent angles, I'm going to mark them with, I'm going to mark the curve with little, these little things right here, if you can see those. So right here I have 2 congruent angles. So this angle is the same as this angle, all right? So these are congruent. However, if you look here, I have 2 different lines going here. So that means that this angle is the same as this angle, is the same as this angle, is the same as this angle. So those are all congruent. So I would mark my second set with 2. It's starting to look like a rainbow. And what if I have a third congruent set of angles? Well then, kind of like with these little lines up here, I would start marking it with 1, 2, 3 lines. And remember, I would mark that on the inside of the vertices. So this particular polygon has two sets of congruent line segments, and it has two sets of congruent angles. And I just noticed that I misspelled this. Let me fix that really quick. Congruent. All right. All right, how am I going to use this information? What do I need to use this information for? Well, a lot of times you are going to be asked whether a polygon is regular or not regular. So you are going to use the information you learned here to be able to tell if a polygon is regular or irregular or not regular. All right, so a polygon is a regular polygon when all the line segments are congruent, so that means that you're only going to have one little notch. You're not going to go to 2 or 3 because all of them are congruent. They're all the exact same length. You're also going to have all the angles congruent. So each one of these angles is the same measurement, okay? It's the same angle. So if I look at this triangle, and it doesn't necessarily have to be a triangle, it can be a lot of different shapes. This triangle is a regular polygon. And if I want to name what particular polygon it is a triangle. So it would be called a regular triangle. All right, now let's look down here. Now if we look at this one, all of the angles in this polygon are the same. So this angle is the same as this angle, is the same as this angle, is the same as this angle. So those are all congruent angles. So why wouldn't it be a regular polygon? Because all of the sides are not equal. So if you look at this one and this one, do you see how this has two lines and this one has one, or these two sides are marked with 2 lines, and these 2 sides are marked with 1 line. That means that not all of the sides are congruent. These 2 match, and these 2 match, but not all 4 of them match. So this would not be a regular polygon. So I would not, if I were asked if this was a regular polygon, I would say, nope, it is not a regular polygon. Also, if I were asked about it, I could say, oops, I don't know what that's doing. All right, so this is not a regular polygon. However, what I can say is, well, it has 1, 2, 3, 4 sides. So I know that if I look back at my chart, that means since it has 4 sides, it is a quadrilateral. All right, and last but not least, we could also be looking at if the sides are congruent. So if you look at this particular, let me move this up a little bit so you can see it better. If you look at this particular polygon right here, you can see that all the line segments are congruent. So this line segment, all 4 of them are equal. So they are all congruent. However, if you look at the angles in this case, this angle and this angle are congruent, and this angle and this angle are congruent, but not all 4 of them are congruent together. So this would not be a regular polygon. Okay, this is not a regular polygon. All right, so using the information that we talked about in the video today, I would like for you to answer the next 3 questions in your math journal. Now remember, I do not need you to write down the entire question. I just need you to write down the number and which choice that you picked. If you are confused by any of them, go back into the video, rewatch where I talked about it, and we will discuss it later in class.